So this is the second day of lesson 5. Today we're going to be working with the angle bisectors. Yesterday was perpendiculars bisectors. Remember the key words that we learned yesterday were concurrent, point of concurrency, and circumcenter. And today we're going to work with the angle bisectors and the key words with angle bisectors in a triangle. So quick peek, angle bisectors do cross in one point, just like perpendicular bisectors did. Okay, so we have our perpendicular bisectors and we have our angle bisectors, and they both do intersect at one point. So you also worked with angle bisectors. The construction of three angle bisectors of a triangle also result in a point of concurrency. Remember, the point of concurrency is whenever the three lines cross at the same point, and we call the point of concurrency with angle bisectors an incenter. So that's our new word for today, is incenter. Just a quick reminder on how to find an angle bisector. We take our compass, we place it on the point of our angle, we set it to some distance, not important what the radius of our circle is. We draw an arc so it intersects both of our rays of our angle. Then we move the compass to the first intersection, and you draw a circle or an arc, whichever you prefer. You move it to the second intersection, and you draw the other intersection or arc or circle. And then you can connect the vertex of your angle through that intersection, and you should have bisected your angle. So your job is to bisect all three angles on the triangle that's in your workbook, and when you're done, come back here and take a quick peek as how we did that. Okay, so I'm going to run through that really quickly. I'm going to take and put my compass right here, draw my arc, move it, draw my arc, move it again to my next intersection, and draw my arc. Grab a segment, grab a ray, make it green, I'm going to make it dotted, and I'm going to go through there. So that's my first angle bisector. Now I'm going to do the same thing from a different vertex. So I'm going to come over here to my vertex C. I'm going to draw my first arc, my circle from centered at C with any radius. Come on. Okay. And then I'm going to move my compass to the first intersection, and I'm going to make either a circle or just an arc, move it to the second intersection, a circle or just an arc, and then I'm going to go up here and grab a ray tool again, and I wanted it to be blue so it matches. I'm going to go from my vertex through my intersection here, and I've got one more side to do. So I'm going to move my compass to my last vertex A. I could make a whole circle, or I could just make the arc so it crosses both vertex or both rays of my angle. Then I could either make a circle from this intersection or just an arc. Again, to go the other intersection, I could make a circle or just an arc. And then whenever I grab my ray tool, and go from A through the intersection, you'll see that they do in fact cross at one point, and I will label that point. And it is my point of concurrency. I don't need my point to be that big. And there is my point of concurrency. And I'm labeling this one Q, because it is different than my other point of concurrency. They will not land on the same point. So point P and point Q will be in different places. So if you go to the number 1 on the top of the next page, state the precise steps in your construction above. I can split my screen here. So whenever I did my construction, you can see that I made the angle bisectors of A, B, and C. And I didn't have to list out all the steps because we've already done that and we know how to make an angle bisector, and you can look those steps up again. So once you've done a construction and we've tested out of it, then you can go ahead and use it. So construct an angle bisector for angle B, and angle C, and label the point of intersection Q. It's good enough. Okay, so let's explore this next piece. We had this picture, I believe, either back in lesson 4 or lesson 3. And in that earlier lesson, we explained why the perpendicular bisectors to the sides of a triangle are always concurrent. Remember, this is our angle bisector, and when we folded along our angle bisector, we noticed that E was coinciding with G, which means when you folded it, E would land right on G, and B coincided with D. We said that segment EF mapped onto segment FG, which meant that EF had to be the same length as FG. And we knew that since EFG was a straight line, and EFJ and JFG had to be the same angle, that each one of these angles was 90 degrees. So now we know that EF is congruent to FG, and that EFJ has to be 90 degrees. So we're going to take those ideas with us and move forward with that thought. So that's pretty much what I just said here, that B to C and C to D are the same length, E to F and F to G are the same length. So if you've got point Q and it's on our angle bisector of ABC, so here is our angle bisector of ABC, this purple line right over here in this picture. We know that Q has to be the same distance to segment AB as it is to segment BC, or line AB and line BC. Now when we talk about distance, we always talk about distance being along a line that is perpendicular to whatever we're talking to. Okay, so that is why I've got the little red square in here, because we've got to be perpendicular. So distance is always along a line that is perpendicular to what you're talking to. Okay, so if we move over to the next vertex, you're going to see that angle ACB also has an angle bisector. And for the same reason, since Q is on the angle bisector, it has to be the same distance perpendicular to AC as it is perpendicular to BC. So these two segments are the same. And if we go to the third side, you're going to see the exact same thing, that this angle bisector has to be the same distance to AB as it is to AC, as long as we're going perpendicular. So now we have this point, and it's got to be the same distance to all three sides of our triangle, as long as we go perpendicular to the sides of the triangle. And so now we have a point of concurrency. Point Q is our point of concurrency. So observe the construction below. Notice that our point of concurrency right here, are these angle bisectors or perpendicular bisectors? Take a moment and think about that. Okay, so they are perpendicular bisectors. So point A is the circumcenter of triangle JKL. And notice that you can draw a circle through JK and L, centered at A, and it will go around your triangle. It goes on the outside. And we call the outside of a circle circumference. Since this is a circumference, it's a circumcenter, and the circle is circumscribed around the outside of your triangle. So that circum is on the outside. So whether it is circumcenter, the center of the circle, that circumscribes around the outside of your triangle. And here's a different picture. On this picture, what kind of lines are the red lines? Take a moment, think about it. Okay, hopefully you came out with those are angle bisectors, and since those are angle bisectors, point B has to be our incenter. It's our incenter. So it is in the center of the circle, and the circle is inside the triangle. And that makes sense because when we were back here, we saw that it's the same distance to all three sides. So this is a radius, this is a radius, and this is a radius. So the circle would have to be on the inside. So we say that the circle is inscribed in the triangle, and the incircle of the triangle is the center of that circle. Likewise, this is the circumcenter of, is in the center of the circle, and it circumscribes that triangle. The circle circumscribes the triangle, is on the outside. The circle is inscribed inside the triangle. So incenter, inscribed, circumcenter, circumscribed. Okay, so on a piece of scratch paper, draw a right triangle and see if you can find the incenter and the circumcenter. In class, we're going to do this in groups, so we can just explore this a little bit more. Then on scratch paper, you're going to draw an obtuse triangle, and you're going to find the incenter and the circumcenter. Oops, that's right. I should have made this one and acute. Oops. There we go. So we're going to do that 3 times. We're going to draw right triangles, incenter and circumcenter, acute triangles, incenter and circumcenter, and then obtuse triangles, and do the incenter and circumcenter, and see what you notice about the 3 things. And then on page 4, or the last question that's going to be done in class, how can you use what you have learned in exercise 3 to find the center of a circle if the center is not shown? Well, ideally, you could draw any triangle you want, either inside the circle or outside the circle. And if you draw the circle, if you've got a circle and you draw the triangle on the outside, you'd find angle bisectors. And if you draw the circle outside, you'd find perpendicular bisectors to get to the center of your circle. So you just work backwards from either one of these 2 constructions. So, things you need to do. Finish problem set number 5. That is your review for the test. You'll notice that it covers quite a bit of what we've learned. Finish anything you haven't finished, and tomorrow is our assessment. And remember that these are our key concepts that will be on that assessment. So be ready. Go back and watch any video you need in order to make sure you're ready.